Hello students, welcome to my channel. Class 12th Ncert Physics activity from section B, activity number 5, to observe diffraction of light due to a thin slit. Aim: to observe diffraction of light due to a thin slit. Apparatus and material required: 2 razor blades, 1 adhesive tape or sellotape, source of light, electric bulb or laser pencil, a piece of black paper, 2 glass plates. Principle: when a beam of light passes through a fine aperture or around a sharp obstacle, it bends around corners of the obstacle or aperture. The light beam spreads and penetrates into the geometrical shadow of the obstacle. This phenomenon of bending of light around fine obstacle is called diffraction and is one of the evidences in favor of wave nature of light. It arises because of the interference of light waves from different points of the same wavefront. 2 razor blades with their sharp edges held parallel, quite close to each other, that is separation being of the order of wavelength of light lambda, form a fine single slit. The diffraction pattern due to a single slit consists of a central bright band surrounded by both sides of colored bands with electric bulb and alternate dark and bright bands with laser pencil of decreasing intensity and fringe width. This is diffraction pattern, diffraction fringes by setup. In this setup, a glass plate, after that a black paper, and the uppermost or topmost 2 blades separating by a fine sharp edge with a small distance. Procedure: make a fine single slit using razor blades. For the purpose, take a glass plate and fix a black paper on the top of it. Cut out a narrow slit in the central part of the black paper. Place 2 razor blades side by side, quite close to each other over the slit as shown in our figure. Place a glowing clear electric lamp, preferably with a straight filament or a laser pencil, at sufficient distance, about 4 to 8 meter, but this distance varies. You may put as your convenience. Behind the fine slit between 2 sharp edges of the razor blades, observe the lamp through the slit. What do you find? Alternatively, place the slit about 0.5 meter from the wall and source of light at a distance of about 15 to 20 centimeter behind the slit. Observe the light falling on the wall. Repeat the observation of step 2 and 3 with a laser pencil. Note the changes you observe. Result: light waves incident on very fine aperture, that is opening, bend around corners and exhibit phenomenon of diffraction. Thanks for watching.